but I'll be on it always, always.
Hi, welcome back to the Pink Chemist. So today we are going to go over skeletal equations. Now, when it comes to skeleton equations, okay, we're going to be given a word problem, and from that chemical word problem, it is expected of us to write out the chemical formula of that word problem. Now, before we get into that, I want you to see here how on the first page, we have a list of common phrases. Now, it does not have to be exact, these phrases, but phrases that's pretty much in this ballpark will help us to identify if we're going to put a plus symbol or a yield sign as we're breaking down our chemical word problem into a chemical formula, okay? Now, I also want to go ahead and note that our 7 diatomic elements are going to be very essential for this lesson as well. Because anytime that you see that you have a hydrogen gas, okay, that is letting you know that the formula you need to use for a hydrogen gas is H2, okay? If you have an oxygen gas, okay, the formula you're going to need to use is O2. I'm also going to write over here on our side our 7 diatomic elements. We have H2, O2, N2, CO2, Br2, I2. Okay, so these are our 7 diatomic elements. Oh, and I'm also missing fluorine, F2. Okay, anytime you see these elements, okay, H2, O2, so forth, these 7 diatomic elements are also identified as gases. Okay, so make sure you keep that in mind. All right, so let's go ahead and get into our first example. Okay, so we have iron 3 chloride reacts with sodium hydroxide to produce iron 3 hydroxide and sodium chloride. So the first things first is that I want to go ahead and identify my reactants. Okay, so I know that iron 3 chloride and sodium hydroxide, my reactant is what my equation starts with, okay? So I see here that these are the elements or the compounds that my equation starts with. And I also notice that I see reacts with. The fact that I see reacts with, I'm going to come down here to my common phrase and look to see if where reacts with fall. And I see that reacts with fall under the plus symbol. So since it falls under the plus symbol, I know that I will be writing a plus sign when I start writing out my chemical equation. Next, I'm going to identify my products. So I see to produce. So if I'm going to produce something, that means that whatever follows is going to be in my products, okay? So I know that from here, I am going to have a yield sign, all right? And then my products is going to be iron 3 hydroxide, sodium chloride, and I see the common phrase and. If I look down here, I see that and falls under the plus symbol. So I know that I'm going to write a plus symbol, okay? So let's go ahead and start working on our reactants. Now, color coding does help with this, especially if you're just beginning. So I know that iron, if I look at my periodic table, iron has a chemical symbol or element symbol of Fe. I also know that iron is a transitional metal. So anytime that I see a Roman numeral, I know that that Roman numeral is basically my oxidation number for that transitional metal. All right. Chloride, element symbol is Cl, and its oxidation number is -1. Okay. And we've already wrote here that when we see reacts with, that means that we're going to write a plus sign. Okay, so do you notice what I'm doing? I'm writing the element symbol and I'm writing this oxidation number first. Okay, then I'm going to go over to sodium hydroxide. I know that sodium is Na on the periodic table with an oxidation number of +1, and hydroxide is a polyatomic ion. And our polyatomic ions, we put parentheses around them. Okay, so that's why I put that parenthesis there. And it has an oxidation number of -1. Okay, so next I'm going to go on. I wrote my reactants, So now I'm going to go on and write my products. But before I write my products, I'm going to write my yield sign, which separates my reactants from my products. So now that I've done so, because I seen that to produce, which let me know I need to write a yield sign, I'm now going to write iron 3 with the oxidation number at the top. That Roman numeral is letting me know that that is an oxidation number. A common mistake that people make is writing that Roman numeral as a subscript, and that's incorrect. And then I have hydroxide, okay, hydroxide OH with a -1 oxidation number. I see the common phrase and, so I'm going to write the plus symbol. And then I have Na +1, Cl -1. Now, how I teach my students so that you can see what is going on. I noticed that when you try to swap and drop, unless you are a master at this, I would not advise for you to skip this step of initially writing out your skeletal equation where you roll out your oxidation numbers first, because some people like to swap and drop in their head, and then what happens is you miss a step. Please do not do that. Please make sure you do this step first to where you write out the element symbol and its oxidation number if it is a metal paired with a non-metal. If it is not an ionic bond, you don't have to do that. If it is a covalent bond, of course, you will write your subscripts in reference to whatever the prefix is in front of that covalent bond. But in this case, our whole equation is an ionic bond. So we have oxidation numbers that we are now going to write the entire formula out for, okay? We're going to write the entire formula out by swapping and dropping, okay? So now we got to go through and swap and drop. Got to, okay? So we have, for our final product, we have Fe, or our final equation, FeCl3 plus NaOH yields FeOH3, because this has to come here, you swap and drop, plus NaCl. And this is your skeletal equation. Remember, a skeletal equation is an unbalanced equation. All right? So let's go to our next example, okay? So for our next example, we got copper 2 sulfide reacts with oxygen gas to produce copper and sulfur dioxide, okay? So let's go ahead and identify our reactant. We have copper 2 sulfide, okay? Our reactant is what we start with. And I see the term reacts with. I see the term reacts with. So since I see reacts with, I'm going to look down at my common phrases. I see reacts with, so that lets me know I'm going to go ahead and put a plus sign there, okay? And then I see that I have oxygen gas, okay? So I'm going to have copper sulfide and oxygen gas on my reactant side. Next, I'm going to go ahead and I see that I have the phrase to produce. So if I'm going to produce, that means I am going to write a yield sign. And then after that yield sign, I see that I have the compound or the elements copper and sulfur dioxide. Okay. And I know that the common phrase and, if I look down at my common phrase, I see that and falls under a plus symbol. So I'm going to write a plus symbol. Okay. So now I'm going to go ahead and write my element symbol and oxidation numbers if necessary. So copper has an element symbol of Cu with the oxidation number of +2. This Roman numeral lets me know that this is my oxidation number for copper, okay, for my transitional metal. Sulfide, the element symbol is S. And sulfide has a -2 charge, okay? And then it reacts. I have a plus symbol with O2. Okay. Oxygen gas. When I see that oxygen gas, remember oxygen gas is a diatomic element, and a diatomic element has to be paired with the subscript 2. So now we have the yield sign because to produce. All right. So now we're going to go ahead to our products. Copper again has the element symbol of Cu. But I notice here, you notice that it's just copper by itself. It is not paired with any other element. So being that it is by itself, I currently do not have to write the oxidation number, because where's the oxidation number going to go if it's not paired with anybody? I see that I have the common phrase N, so I'm going to write the plus sign. And then sulfur is S, and oxide, dioxide. The fact that I see a prefix lets me know that I have a covalent bond, and di means 2, so I know that this means that I have SO2, sulfur dioxide, okay? So now I have to go back and complete my actual formula, because initially I wrote out everything step by step. Now I have to complete my formula, okay? So, and in order to do that, I must swap and drop. So I have CuS, because I know that these twos, because they are the same, once they drop down as subscripts, they will simplify to be 1. And then I have O2 yields Cu plus SO2. Now remember, SO2 did not need to be swap and dropped. It did not need oxidation numbers, because SO2 is a covalent bond, and for covalent bonds, we do not swap and drop. We have prefixes to help identify our subscript, and we have written out our skeletal equation, okay? All right, let's do our last example. Okay, so when dissolved beryllium chloride reacts with dissolved silver nitrate in water, aqueous beryllium nitrate and silver chloride powder are made. All right, so let's go ahead and identify this. Okay, so most people, you probably want to check out because you see dissolved, you see aqueous, you're probably like, what does this mean? Please do not get thrown off by these, the state in which these elements are in. That's basically all that is being that this is telling you, okay? So we want to make sure that we're pulling out our focus in the skeletal equation is to pull out our reactants and our products. That is our focus. These other extra words are not going to take you away from being able to pull out what it is that you need, okay? So don't get discouraged by that. So first things first, I want to look for my reactants in here. So when dissolved beryllium chloride reacts with dissolved silver nitrate in water, boom, here are my first compounds. I have beryllium chloride, okay, reacts with dissolved silver nitrate, okay. I see that these two are going to be in my reactants. Now I'm going to go back also because I see reacts with, which when I go to my common phrase, I see that reacts with means that I'm going to have a plus sign. So I know that this plus sign is going to separate my two compounds. And so for those of you that might be confused thinking that you might need to add water because it's saying that silver nitrate is in water, you do not have to add H2O to this. What it's basically just saying is that silver nitrate dissolved while it was in water. That's it. It's not telling you that water is a part of this chemical formula or this chemical reaction. Is just that silver nitrate was placed in water, okay, and it dissolved there. All right. Same thing with aqueous. It just means that it's in water, okay. So I know that after my reactants comes my products, and in order to separate my reactants from my products, I have a yield sign. So I know that after this, whatever elements come after this, that is going to be my products. So I have aqueous beryllium nitrate. So boom, that compound, that's my product. And then silver chloride powder are made. So I see made. The fact that I see made, I'm going to go down to my common phrase that lets me know that a yield symbol needs to be there. Now notice the yield symbol, when I know that I have to write a yield symbol, it does not have to follow the structure of the actual chemical word equation. I just know that if these elements were made, that means that a yield symbol needs to separate these compounds from the reactant. Okay, so that's kind of how that works. All right, so let's go ahead and start writing out our actual oxidation numbers and elements. So you have Be, Cl, -1. I see that I have react, so that's a plus sign, with dissolved silver nitrate. Silver is Ag, and Ag is a transitional metal. And being that they did not give us that transitional metal, I know that it is +1. Nitrate, NO3, -1. I wrote my reactant, so now I know that the next set of compounds are going to be in my products. So I went ahead and wrote my yield sign, okay? And then I have Be, NO3, -1, plus Ag, +1, Cl, -1. All right. Now, one of the things that I need to do right now, I have to go and get my oxidation number for Be. Okay. My oxidation number for beryllium is +2. Okay. So it's +2. Now that I have my oxidation numbers set out, now I have to go back through, because now I got my element symbol, my oxidation numbers. Now the last thing that I need to complete my chemical reaction is to get my subscripts. And in order to get my subscripts, I have to swap and drop. And swapping and dropping is when you're taking these oxidation numbers and dropping them as subscripts. So I have Be, Cl2 plus Ag, NO3. And we know that for ones, we do not write our ones as subscripts. Okay. Then I have Be, NO3. 2 outside of the parentheses when we swap and drop, plus AgCl. And we're done.
Don't play with it, don't be dishonest. Ay, still not